So let's start with basic statistics, right? So generally you have something called as measure of central tendency. Okay, as the name suggests, central tendency. How close are you to the center? Okay, now I'll give you an example. Let's say if I tell you that I'm going to start class at 7 p.m. and I start at 8, do you like it? No, right? If I tell you again 7, I start at 6, will you like it? No, right?
No.
Because you're not prepared for 6 or 8, right? We want it to be as close to 7 as possible. That's a commitment. 7 p.m. is, and it's not possible to start at exact 7, right? Because it's not possible to do it exact 7, right? 700, 0 minutes, 0 second, not possible. So you will be either early or you'll be late. But thing here is how much early, how much late you are. If you are a few seconds early, couple of minutes early, couple minutes late, it's fine. But you don't want it to be half an hour early or half an hour late, right? So we're talking about how close are you to the commitment date, and even early is not possible. Let's say you book a car and your waiting period is 40 days. Okay, and then after 15 days they call you saying that your car is ready, please make the payment and take it, otherwise we have to give it to somebody else. You will not like it because for the payment and things like that you would have made a plan. Okay, that okay, you have 40 days, then you would have planned that way. Maybe you are out of town, you are traveling. So we don't like things, and that's from the status perspective. Even early is not good, even late is not good. You make a commitment and it has to be on that commitment. Okay, so how do you know, okay, that whatever commitment has been done, you are meeting that commitment? So for that we use three kind of metric. We use mean, median, and mode. Okay, you see this here, my cursor, mean, median, mode. So these are the three metric that talks about measure of central tendency. Okay, how much close are you to the commitment time? Okay, we say expected value in statistics. Expected value means the value that you expect, but of course you can't get exact value. So how much deviation have you done from that expected value? Okay, deviation is without the sign. Okay, so that's where the absolute value comes into picture. Absolute value means what? So 5 minus 3 is also 2, and 3 minus 5 is also 2, right? We don't give importance to the sign there, because okay, if your commitment date is 15 and you do 12, you're doing 3 days away from commitment dates. So whether you do 3 days before or 3 days after doesn't matter, right? You have missed the date by 3 days. That's what it means. Okay, the sign doesn't matter that much there. Okay, so that's what mean, median, mode means. Now mean is same as your, how do we calculate it? Okay, so mean is same as your average, right? So mean is same as your average. So if you have n numbers, so you add all of them and divide by n, right? Average is called as mean in statistics. So average means you add all the numbers and divide by n, right? If you have n numbers, you divide by n. So that is your mean. What is median? Median is the middle value. Okay, so to find median, you have to split the data. Before splitting, you have to arrange the data in either increasing or decreasing order. We prefer increasing, but even decreasing order will give you same result. So you arrange the data in increasing order, and then you find the mid value which is exactly at the middle. So if you have odd number of values, right, here you have what, 9 numbers. So for 9 number, it is easy, right? This fifth number is a mid value. So fifth value divides it into two data set, right? You have 4 values on the left, 4 on the right. But if you have even number of data, okay, so in this case you have 10 data, right? So there are two mid values. So 21 and 44 here divides the data into two halves, 4 on the left, 4 on the right. So in this case, we take average of these two values, mean of these two values. So when you have odd number of numbers, then you'll have only one answer as your median. But when you have even number of values, then you'll have you'll have two mid values. So you take average of the two mid values, and that is your median, right? So in this case, median is average of 21 and 44, which is 32.5. So 32.5 is the median of this data set, and here it is 21 easily. So we know what is mean, what is median, and mode is about the maximum occurring number. So if this is the data set, okay, which number is occurring maximum number of times? 5. 5 is occurring thrice. So you have 5, which is the mode of this data set. 15 is occurring twice, 44 is twice. Okay, so of course these are not your mode, this is your mode. So now you know what is mean, median, and mode. Median is the average. Sorry, mean is the average, right? Median is the mid value, and mode is the maximum occurring value, right? And your data set can have 2 mode, 3 mode, 5 mode. Let's say 15 was also twice, thrice, 44 was also thrice. You can have 3 modes, okay? So when you have 2 modes, it's called bimodal data set. And more than 2 is called multimodal. So when you have multimodal, that means it has more than 2 modes, which is possible. Okay, so this is an example, okay? Now, let's say this is 2 schools, and these are the marks obtained by students of their school and 10th class board, okay? And this is the marks that you see, okay? Now you tell me, okay, based on your understanding, which school has overall done a good job, okay, in terms of like performance. So what do you get from this data? Your opinion, okay? Don't worry about being right or wrong, okay? Because in such subject, there's nothing called right or wrong, okay? There's nothing called this is right, okay? In statistics, especially when you are doing for analysis, so we always say the experience will score over statistics, okay? Statistics is something else, but your experience is something else. Sometimes you see that, okay, if everything could have been done using statistics, right? So every business would be same. They will have same revenue, same profit, same same problems, right? That's not the case. So business statistics is just one input parameters, but ultimately it is the decisions makers what do you call, like their risk that will actually help to gain or lose clients, right? Or gain business. So what do you think when you look at this data set?
School A performance is good, it seems.
School A performance is good, so justify it.
And if you see that they have a good in mean, median, and mode, the average they have.
Mm-hmm. Correct. Okay, so yes, you're right. If you look at average, okay, probably A is doing good, right? So the students there are scoring better, right? Students there are scoring better. And if you see the the values, its average is obviously 70% compared to school B. Okay, but now if you look at the performance here, mode is 99. What does mode indicate? Mode indicates maximum number of student. So even though average is less, but the mode is high. Okay, mode is high. That means most of the students have got 99% marks, but still the average is low. That means there are, and assume that this is not there. Okay, you don't have this data. Okay, assume that this data is hidden from you. You just look at this and you're trying to make your assumptions. So when you have this, what it says is mode is very high. Okay, mode is very high, right? And average is less. So it means that there are many students who might have failed also, right? If your average, like it's like let's say, in two subjects, you got 9900, but your average is 60. That means other other four subjects, probably you got very poor marks, isn't it? That's why your average is 60. So, so what it tells you is that and again, you look at the mean and median. That's another factor to look at. Mean and median, if you look at, almost same, right? So we say that data is evenly spread. Okay, data is evenly spread, and okay, I'm not looking at this one, okay, but you can make from this one. Mean and median is almost same. That means data is kind of equally spread, okay, across mean and median, across your mean value. But here the mean and median data is too much of difference. Okay, so here there are more people who have performed according to average. Based on around average, there are more people, but here there are contrasting students. Okay, mode is 99, mean is 65, but median is 43. So very contrasting. So there are some who have scored very high marks, and there are some who have scored very low marks. So this is how we look at mean, median. You should be able to say. Now I'll take an example and we'll talk about it. Okay. Can you see my Excel? Probably now you'll be able to see my Excel. Okay. So let's take some example here. Okay. Let's start a data with 15. Okay. And 16, 17, 17, 17, 18, 18, 18, 18. Then I'll go 4, right? 19, 19, 19, 20, 20, and 21, right? Let's say these are the numbers that we have. Okay, so these are the numbers that we have. Let me make it bold and okay. Now, what do you think is the mode here?
18.
18, appearing almost 4 times, isn't it? Mode is 18. What is median and mean? So let's do mean. Mean is sum of all these values divided by how many values are there?
I guess 6.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Correct? Right. 16. So what do you get? 18. Right? Now look at the median. So 16 means there will be 2 values, right? 2 values, right? So you'll have 7 on the left, 7 on the right, and 2 will be middle, right? 3, 4, 5, 6, 7. 7. So if you take here, right, this is your median values, right? So 7 on the right also, correct? So what is average of 18 and 18?
6 by 2.
18 only, no? If both are
18
same, it
only.
will, yeah.
Yeah.
Okay. So see, when your data is normal, this is called normal data, okay? And we'll talk about again when, in continuous values, this is anyway discrete values, right? I have, okay, how do I say the complete screen? Okay, let me show the complete screen. Now, here, if you talk about this, okay, normal data is something like this, okay? You have less data on the, I told you, right? If you look at the world, right? Most of the values will be around your average. There will be very few value with very high extremes, right? If you take height, very few value will be, people will be more than 6 feet, 7 feet. Okay, there will be maybe one person is with almost 8 feet, let's say, possible. But there will be very few values. As you go on the higher, average is, let's say, 5'10" or 5'9" for Indian male. So if it is 5'9" for Indian male, most of the male you'll find will be around 5'8" and 5'10", isn't it? As you go here, maybe somebody with 4 feet, 4.5 feet will be very few. There will be, but very few. You got 7, 8, it will be very few. Okay, this is what we call normal data. Okay, you take weight. If 70 is the average, 60, 70 is the average, you'll have many people around 60 to 70 kg. Somebody with 200 kg will be very less. Somebody with 40 kg male, I'm talking adult male. Okay, 40 kg will be very less. Okay, you take marks. Marks, if 70 is average marks or 65 is average marks, most of the people will be in this range, 60 to 70 range, around average. Very few will get 99 and very few will get 30, 40 failed. Okay, so this is the nature of data. Nature is producing such data, right? And in practically also we see such data only. Okay, so that's why this we call it as normal data. If you see here what I did, I have very few with very low value and very high value. When you come towards right, it slightly increases. Okay, and around average you have more values. So when your data is normal, your mean, median, mode, all three are same. When your data is normal, your mean, median, mode, all are same. Okay, or almost same. Okay, so when you see mean, median, mode, all three values same, you say that data is same and it is spread something like this. Okay, it has spread something like this. Most of people with 70% marks, very few with 80 and 60, very few with 90 and 50, 40, like that. That's what the data would indicate. Okay, now let's say I add another value here with 100. So I'm adding 100. What has happened if I add 100? What will happen to median, mode? Okay, let's look at mode. Will mode change?
No.
Mode will not change, right? Mode will remain same. Okay, because if you add one or two value, mode will not change. Mode is talking about value which has maximum occurrence, right? So you have to get too many people with 100 marks in order to mode to change. Otherwise, your mode is not going to change, right? Mode will be same. What happens median?
It's same only, middle value.
Correct. So now it is this one, right? Okay, now it shifted. So it is shifting. So 18 did not become 20 or 21, but it has shifted a little bit this side, isn't it? Okay, if you add one more value, let's say I add 50 here and I add 50. Purposely I'm putting increasing order, right? So that it's easy for us to calculate median. This is 80. Let's say this is 100. So now what happens to the median? We added high values, but so what we are doing, no longer it is normal. What we are doing is, this side it is normal, but I'm adding more number on this side. I'm adding a tail on this side. That's what it means, isn't it? So see here it is mirror image. Both sides are same. But here I'm adding more values on the higher side. So your value is going, okay, you're getting higher value on this side. So our mode remains same. Mode is this high value. Okay, histogram. This is your mode, isn't it? So in this case, mode, mean, and median, all three are same. 18. All three are same, which is 18 in our data set. Correct? But when you add higher values, this is your mode. Mode will remain same. Mode will not change. Just because you add few couple of high values, mode will not same, because mode will wait for many values to be added. So mode will remain same. What happens to mean and median? So in this case, what happens to median? Okay, so we have how many? 16, right? 16 plus 3, 19. Now we have 19 values. So this was for 17. Okay, 17, 18, and 19, right? Probably. Sorry, we don't have to save it. Okay, so we have got 19 now. 19 means you need to have 9 on either side, isn't it? So 3, 3, 6, and 19. Okay, you have, this is your median now. Okay, now let me add one more. Okay, just to make it different mean. Okay, let me add 110. So now if you have added 110, that means your median is now average of 18 and 19. Okay. It is average of 18, 19. Tell me yes, Pavni, you there?
Yeah, I'm here. I'm on mute.
Okay. So now it is your average of 18 and 19, correct? Now we added 20 values, 16 plus 4, 20. 20 means 9 on this side and 9 on this side, right? And you get average of these two. So, you know, your median has also increased, but very little. But what happens to mean? So mean, okay, and you take, you can simply say average. Why am I doing sum? I can do simply average, right? Average of all these numbers together. 31. You see? This is what we saw in the case of B, right? The school B. Mean is very high. Okay. Median is less. So there's so much of difference, almost twice. Mean is almost twice of median. That means we have got higher values on the right. So what happens is, okay, we always assume the data is normal, right? And then we compare, okay, why there is abnormality, why there is a difference. So when you add a higher values on the right side, your mode will have no impact, absolutely no impact. Because you're adding 4 or 5 values will not impact mode, because mode has, is based on the highest occurring value. So mode will not have any impact. Your median will also change. Median is moving in which direction? Right side, higher value direction. Mean is also moving, but mean will move much faster. Mean will median is moving very fast. When I'm talking here. 1 second. Yeah, sorry guys. So here you see median is moving towards right, okay, because we're adding higher value. So median will move towards right, okay. But it is not moving by a faster rate. You can add 0 or minus here. If you add here, median will move this side, okay. But what happens to mean? Mean moves much faster compared to median, right? So if you go back to the graph that we're talking about, so your mean will be here, right? Mean is moving much faster. Okay. And median will also move, but median will be here. Okay. So when you have a higher value on right side, mode will not have any impact. Median will move slightly and your mean will move much faster. Right? So that's the impact of the data on your 3 matrices. When everything is fine, then nobody is bothered, right? Everything is going great. But what happens? There is a process, there is a problem in your process. Okay, process is taking more time to perform. How do you realize that? Okay, is it abnormal? Is it different? Okay, so when you have a higher value, okay, if there's a change in the process, your mean, median, mode will start behaving differently. So mode is not behaving differently, rather your mean and median is behaving differently. Okay, so mean, okay, moves much faster compared to median. Mean is moving much faster compared to median, right? Okay, so now you tell me, which one do you trust more? Mean, median, mode. Which one generally is more significant? You tell me. Now, when data is normal, all three are same, so it doesn't matter. But when data is not normal, which one do you think will get more importance?
According to me, it's mode, I guess.
Okay. Why?
Because like if we talk about a school A, so many of the student got 70 marks, so we can say it's a good, like most of the
No, see,
uh,
but mode is not telling you, right? Mode because of some change in the data set. Mode is not changing. Okay. If mode is not changing, it doesn't tell you anything. Right? Look at this data. Right? So I'm just, I took some random data and I'm trying to show you. Mode is not getting impacted. If mode is not getting impacted, then what's the, you will not be able to know. Even if your system crashes, the server is down, okay, you will not even know. Okay, because your mode is not changing. So if you focus on mode, you will not be able to know if the process is doing good or process is doing bad. Okay, it is mean and median which is actually will tell you what's happening to your data set, right? So statistically, mode is not that significant. Okay, if you look at these three metrics, these are three metrics for central tendency. So your mean and median will tell you something. Mode is not telling you. Okay, mode is same, there's no reaction. India loses also no reaction, India wins also no reaction. So it doesn't tell you what the result is. Okay, if you talk about median, if India wins, median will smile. India lose, frowning. But mean will be jumping up and down. If India wins, crying if it is not, if India loses, right? So, well, look, if you look at the mean, you will actually see what has happened. If you compare your mean and median, you'll actually see what has happened, right? What has happened? If you look at mean, it'll tell you, okay, there is if okay. So see, when you look at median and mean, that's what I said. If they are in almost same range, then there's not much change in the process. You are okay, not much change in the process. Okay, but if mean is here and median is here, MD, let's say, and your mean is somewhere here, okay, that means that
there
this
is
one
some big
has,
change.
there's some big change, there's some process which is taking more time than normal. There is something that is performing good or bad. It could be good or bad also. Let's say if you think that taking more time is good, then this process is doing better. Process is better. If you think that taking more time is bad, then this process is bad. Like if you talk about marks, if mean is greater than median, then you know that there are few people who have got good marks, right? If you talk about your generally they talk about the salary, right? Okay, so the B schools, business schools, they only talk about their average salary. They don't talk about the median salary. If you look at median and mean, then you'll able to get the picture. They'll tell you, oh, average is 35 lakhs. One person got international placement salary, very high placement, high because international placement, right? Got in dollars, so it will be skewed, right? So average suddenly, which is average is like 5 lakhs, will become 10 lakhs because of just one guy, which is not good, isn't it? So in such case, your mean can give you a false picture, right? So there we should trace the median. Just because you have one or two, out of 20, out of 16, 4 data set is totally skewing. Okay, the word is called skew, and we'll talk about it in some time. Skew means changing the shape. It's not normal. There is something abnormal in it. Just because of one data, your entire thing will move either left or right. So colleges, they will see the data which looks better, and they'll tell you, oh, average is 9 lakhs. How many international placement? 10 international placement with 50 lakhs, 60 lakhs. Okay, and domestic placement is 4 lakhs, 5 lakhs. Data will look like 12 lakhs as average, right? not good, right? So that's why I'm saying, so it depends upon what you want to understand. You have to look at both mean and median. Median, okay, is when you want to ignore the outliers. Now, mean will tell you there's something wrong with the process. So if you have to fix the process, if you're looking at your process, you have to track mean. Okay, mean, very high mean, very less mean, there's something wrong with the data. Compared to median, that's what I'm trying to say, okay? Because see, when I say mean is 900 and mean is 90, which is better? Mean is 900 better or mean in 90 is better? You can't say, because here all the data could be high, here all the data could be low. So just by comparing mean and mean, you can't say, okay, this could be measuring something else, this could be measuring something else. This could be gram and this could be kilogram, right? So it's not, they're not apple to apple, right? We can't so we can't compare. We can only compare apple to apple. So that's why comparing two mean doesn't say anything. Let's say if my 10th class total is 900 and your 10th class total is 700, who is better? Maybe this board has 15 papers. I got 900 out of 1500. You have only 8 papers. You got 700 out of 800. Your marks is better, right? Not 900.
Yeah.
So you can't compare the absolute values. We have to compare two values. Then you see, okay, mean and median. Then you say, okay, if median is low and mean is very high, that means there are some values on the extreme end. If mean is low, if mean is on left side and median is on right side, that means there's some extreme low values, which is kind of tilting or skewing your process. But now if you look at the performance, if you want to evaluate a performance, we tend to ignore the outliers. We don't want to consider outliers into analysis to measure performance, right? Okay. So just because one day I was late out of, let's say, 50 classes, okay, doesn't make me latecomer. Maybe I was late for 1 hour one day for some reason. We had 50 classes. I was late for one day for 1 hour. Doesn't make me latecomer, right? So such situations you need to look at median, not mean. You understood? So statistically, median has very little or no role to play. Sorry, sometimes I also forget what I'm saying. Mode has no role to play. Okay, let me write it, then it'll becomes better. Mode almost has no, okay, so there could be some situation, but almost no role to play in the statistics analysis. Okay, but if you talk about median, okay, median, if you want to measure the performance and ignore the outliers, then this is what we prefer. But if you want to see, if you're tracking the process, if you want to see how the process today, then mean can be a better choice. If you want to perform your monthly performance, then median is preferred, not mean. But if you want to perform, you want to measure today's performance, right? What is happening today? Then you will do mean. Okay, median just tells you what is the high value, doesn't actually tells you more than that. So I'm not saying absolutely no, but very less, it does not have much role to play in the analysis. Right? So this is why your mean, median, mode are all three important. Okay, so this is discrete values. In continuous values, as I said, we do in terms of range, right? So what we do, we actually create a range 0 to 9, we make as one value, 10 to 19, 20 to 19. We have done this before, right? Histogram. So we create range and then we look at this value and then we start plotting. Okay, when you have continuous values, then it does not make sense to take each value as one. Then your mode will be all will be mode only. So we take range. Range you can decide like in a step of 5, a step of 10, 15, 20, depending upon how many data you have. And more than that, depends upon what is the range of the data. If range is much higher, then your bucket size also be bin size. We can say bin size. Bin size will also be higher. Okay, so that you tend to get 8 to 12 kind of bars you need to get. Okay, so in here we don't look at each data, we will group the data. Okay, so now if marks were possible in decimal, let's say 50.1, 50.2, 50.3, Then you have to take 50 to 51 as one group, 51 to 52 as one group. Okay, and then you say, okay, between 15 to 51, we have 50 people. 60 to 61, you have 30 people. So, that's how you create, and then you plot and you perform the analysis. Okay, so let's look at this one. So Rajesh is a branch manager, and he wants to find out, should he open a new counter at his bank or not. So you have this counter, right, for cash withdrawal and cash deposit. So he wants to know whether, whether he needs to open when opening a new counter means you have to hire one new person for the bank. So does it make sense? Okay, so you see, so again, if you start, let's ignore this one for a minute. Let's say customers are complaining that they have to wait a long time, right? They have to wait for 30 minutes, 40 minutes to get their chance. So just because they're complaining, you will not start opening, right? You want to measure and see, is it really worth doing that? So then you go back and you measure, you sit in a corner from morning to evening, you start noting down. Customer 1 came at 9 and went at 9:05, so 5 minutes wait time. Customer 2 at 8 minutes. And then you make a list. So you see that most of the values are between 0 to 10. Okay, there are only few values between 10. So this is peak time when everybody is coming. Most of people are coming at the same time. Here you have 30 minutes also wait time. But there it's only contributing 10% of the data. Okay, if it is only 10% of the data, then it probably doesn't make sense for you to open a new counter, right? But if it's like, if it is like 50% of the data, 70% of the data, then you know that it's time for you to open a new counter. So for this, again, you will take mean and median and mode. Okay, you always have mean, median, mode. Okay, and if mean is higher, okay, and mean is lower, that means, okay, there is a one-off case. There would be very few people are coming. We have to wait for long time. Okay, but if mode and median both are high, then it's time to open a new counter, hire a new person. You'll ask your head office to send you a new employee to manage a counter. So you'll get a business case for that, right? So this is how you can use it. Let's go back here and see what is the example. So yeah, so same thing. Okay, so observe and write down the time spent by each customer, and this is the time. And then he started plotting this graph. You see, so between 30 to 40, there are 3 customers waiting. 40 to 45, so many customers. Okay, so they have created this. Now what does this tell? Okay, it tells you that majority of the customers are waiting from 35 to 50 seconds or minute, whatever. So don't go by the numbers. I'm just telling you how it looks like. So if majority of customers are waiting for 35 and 50 seconds, definitely it's not worth hiring a new person. But if it was like 30 to 40 minutes, then probably. And also see, as a company, you also decide at what range you want to play at. Okay, now, okay, the bank where service rates are very high, talk about HSBC Bank, Citibank, they have very high value customers. So they might want to say that I don't want my employees to my customers to wait for more than 10 minutes. Okay, so for them, even someone waiting for 10 minutes is a big deal. They would get up someone at the counter. But if you talk about SBI, okay, SBI, most of them are low value customers, right? So for them, 30 minutes is also not too late. So as a process also, you just need to decide, okay? You can't compare two process. As I told you, right, when you have to compare the two process, you have to always compare apple to apple, right? You also want to compare within your segment, okay? SBI and Citibank, they are not competitors, right? Citibank might want to compare with HSBC and other banks, okay? SBI might want to compare with SBI and other bank, right? Which falls in same. So you look at the number of customers, look at the average value, average deposit that customers are making, so you look at those parameters, okay? And then you say that, okay, 10 minutes is Now for government school, maybe I'm just giving you, now, this is called bias actually, okay? Bias means without any data, you're talking about it. So maybe for, for a school which is charging high fees, for them, a mean median of 60 is considered very bad, right? Mean median of 60% is very bad. Maybe a school which is charging low fees, for them 60 is maybe a good number, right? 60% is good, median average. So you also have to compare. So you don't only just compare the numbers, mean, median, you also compare if they are in the same segment. Are they actually competing with each other, right? And if you say the school 1 and 2 are same kind of school, the fees is same, the kind of people that go there are same, then definitely there's a problem with that number. It shouldn't be so much of difference, right? So coming back here, so so this is how your mean median mode will impact your business. So clear on mean median mode. Now when you look now, from the data, see, these are very basic statistics, but the kind of information we get is very powerful. Are you able to understand the significance of this 3 term?
Yeah.
Right? So, which probably in school would have just done it. But you see here in analysis, it plays a very important role. Okay. You have to look at the number and see where it lands. Okay. And what kind of impact it can have on a business. Okay. When should you look at mean? When should you look at mode? When should you look at median? And this is what we did yesterday. Okay, so I'm not going to talk about it. This is about temperature versus sales. Yesterday we did hours versus marks, right? This is like temperature versus sales. So this is a shopkeeper. He wants to know how much ice cream to carry every day. He probably, let's say he has a shop on beach and you have to carry the inventory every day. So you don't want to carry a lot of inventory when customers are not there. You don't want to carry too less inventory when you're expecting more sales. So this guy is sitting down and noting down everyday sales, and he is able to he's able to understand that there is a correlation between temperature and sales. If temperature is high, sales are high. So this is what his data is saying. So as temperature is increasing, the sales is also increasing, right? So he has noted down his daily sales. Day 1, maximum temperature was 25, sales was 3,400. Next day, temperature was 32.8 degree and the sales was 4.5. Okay. So with that, but look at this number. By looking at this number, you won't get anything. Okay. So in this case, you have to plot a scatter plot. You plot a scatter plot, you see that as you increase the temperature, the sales is also increasing. That means your temperature is having a positive impact, positive correlation on your sales. Okay, so here we are seeing that as the temperature increases, okay, your sales is also increases, right? So now what you can do is daily morning, you look at the weather forecast. If the weather forecast says the temperature is going to be 30 degrees Celsius, okay, then 30 degrees Celsius means your sale will be around 4,000 rupees. So you will carry inventory worth of 4,000, 5,000. Okay, extra inventory just in case there's a surge in demand. But if they say that temperature is going to be 38 degree, 37 degree, 36 degree, you know that you can make even 7,000, 8,000 rupees. So now you'll carry twice the inventory. The temperature goes to 35 degree. Right? So this is how you can use simple statistics for your business. So this is what exactly that we did yesterday. Okay, so then we talk about different types of mean. Okay. And what we did is called arithmetic mean. What we did just now is called arithmetic mean. Okay, so we know what's the meaning of arithmetic mean. Okay, you want to find the average value, that's arithmetic mean. Then we have geometric mean. Okay, so how does geometric mean work? Geometric mean is nth root of x1. So if you have 5 values, if let's say if you have, for simplicity, I use 5, 5 only. If you have 5, 5, and 5, and 5, okay? So what you do, geometric mean, or we call GM, right? Geometric mean, is fifth root of 5 into 5 into 5. So which is again 5 only, right? 5 to the power 5 and root of 5 is 5 to the power 5 by 5, which is 5 only. Okay, so in this case, you get 5. If numbers are different, you will get different value. So if numbers are same, your AM and GM are same, isn't it? Arithmetic mean will also be 5 plus 5 plus 5 plus 5 by 5, which is 25 by 5, 5 only. Geometric mean is also 5. Fifth root of 5 to the power 5 will also be. So if the values are same, if there is not much difference in the value, the spread is less, they will be same. Okay, now what happens if spread is more? Okay, let's say we'll go to, yeah, this is empty, right? So let's say you have values like n1, n2, n3 is like 5, 6, 7, 8, 9. So your average will be 5 plus 6 plus 7 plus 8 plus 9 divided by 5.
5.
This is your average. And your geometric mean is going to be 5 into 5. 5 into 6, sorry. 5 into 6 into 7 into 8 into 9, and then you perform the root. Today we saw how to perform power, right? Double star. So you first calculate this, and then you say double star 1 by 5. 1 by 5 is 0.2, correct? And you can print average and geometric mean. Okay. So see here, average is 7, geometric mean is 6.8. Not much deviation, right? Almost same. Now, as you keep on increasing the gap between these values, the difference between AM and GM will be different, will be higher. So I think I have the significance also written here. Okay. So it says, geometric mean machine learning is in the calculation of so-called G-mean. That is a model evaluation metric that is calculated as geometric mean of the sensitivity and specificity metrics. So it talks about sensitivity. Okay, as you increase these values, as you keep on increasing, let's say if I make it 90 here, then what is the difference between AM and GM? Okay, there's a lot of gap. So what it says is your average, you see, okay, same problem we saw, right? Just because one value is outlier, so just because one value is higher, your mean has increased to 23. Okay, if you remove 90, the average will be somewhere around 6.5 or maybe 7. But with 90, it became 23. See, so far it went ahead. But your geometric mean also is more than 5, but not very high. So when you have these outliers, then it's better to use geometric mean than arithmetic mean. You see this? Your geometric mean is not increasing by a very large value. It's increasing, but with a small value, right? So average, if you do with this, okay, now let's calculate same thing without 90. And then we are going to compare, then it will be easy to compare, okay? So if I remove 90, it is 4, correct? And remove 90, it is 0.25. So see, 6.5, 6.4, almost same, right? But just because when we got one outlier, see your arithmetic mean increased from 6 to 23, which is very high. It increased from 6 to 10. So sensitivity analysis is used when you want to change what happens if I increase this, how much impact it will happen. So arithmetic mean is always running faster, either side. Okay, even if you put a small value, it will go drastically down. Okay, and in analysis, we don't want these people, who are running very fast. Just because one value is higher, it shouldn't increase by a lot, right? So you see, GM is performing better when you have So again, you compare AM and GM when you're analysis and you're performing analysis. GM will tell you if it is just one value which is very high or all the values is very high. If you have all the values very high, obviously GM will also be high, isn't it? If all values are high, GM will also be high, 68, right? But just because one value is high, your GM is not going to change much. So this is another metric that can be used to measure your sensitivity. Then you have harmonic mean. Okay. So harmonic mean is 1 by, okay, it's like performing inverse of your AM, arithmetic mean. It is inverse of arithmetic mean. So how it, HM, harmonic mean, is, okay, your 5 divided by, okay, 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8. Okay, we'll do 1 by 8 here. So now if you see, and we'll print HM first. So see, HM is also in same range. But if you add, let's say, one more variable, 6. Okay, we'll add HM here with 6. No, it is only 4, right? Not 5. Here it is 5, correct? And then we add 1 by 90. So here, did we get it right? Yeah, when you have high, it increased all. No. Yeah, it increased, right? It is 7 here. Okay, it is 6 here. Now when values are, see, values are almost same, right? Just like mean, median, mode, you got means also in same range. Okay, with outliers, values will be different, 7, 23, and 10. Okay, so this is another way to measure. Okay, and you actually can represent this using mathematics, but that's okay. I mean, we don't have to get into this. So this talks about the relationship between AM, HM, and geometric mean. Okay, so that's okay. But you understand here, okay? So see, if the values have same unit, okay, we use arithmetic mean. If values have different unit means one is gram, one is kilogram, then your geometric mean will give you better result, right? Because the higher value is also kind of equalized. So if I tell you, I've got 5 apples, 6 oranges, 5 grapes, okay, all are different. In that case, better to use geometric mean. And if values are rates, percentage, so if I tell you what is the, see, if I give you absolute number, AM, GM is better. But if I give you percentage, okay, this contributes to 30%, other contributes 40%, third contributes 50%. What is the average contribution? Okay, it is in percentage, it is in ratio. And then if I ask you what is the average contribution, then you go for harmonic mean. Okay, so this is all. But in our data analysis, we are not going to talk about percentage. We are not going to talk about different unit. So mostly our analysis will stick around mean, median only. But yes, when you have different metric and you don't know what to do, perform geometric mean, because geometric mean will bring high, low value to the same level, like median. Okay. So we'll stop here. Did you understand what each of these things mean?
Yes.
Okay. One last exercise we'll do before we end the day. So this is your distribution of annual household income in US 2010 data. Okay. So what does this data tell you? Forget about the numbers. By looking at it, what does it tell you? What could be mean, median, mode? What your guess? Okay, guess. What is mean, median, mode? Your guess.
Here it's mentioned median household income was roughly 50,000.
Yeah, so see, this is your mode, right? Mode is the highest. So most of
Right.
the household, that means most of the employees, this is your discrete data or continuous data? Is it discrete or continuous data? Tell me.
Discrete.
No, continuous. That's why taking range.
Con-
Under $85, 85,000 to sorry, 8,000, no, 5,000, sorry, dollar. So under 5,000, 5,000 to 10,000, 10 to 15, 15 to 20, 20 to 25. So you're grouping them, right? So it is continuous data. That's why you're grouping them into the groups of $5,000. So most of the household, right? Most of the people, they get between $15,000 to $20,000 per month. That is the average household. Okay, and then expectedly this will decrease, right? You will have very few houses will get higher and higher. But you see, suddenly what happened? The last two group you see, they're very high. These are like, maybe super duper rich guys, the owners of Microsoft, Google, and things like that. Okay, Tesla and Facebook and these guys. So these guys, there are many household that has very high, right? So it says that
Because
two
of mean.
group. Sorry.
It's a mean.
No, it's a data. It's not mean. It's all data only. Okay, mean will be somewhere here. If this is your median,
Your phone. This is the phone holder and this is the mouse.
so you see that. So this is median, right? So median will be closer to mode. Average will be somewhere here. Okay, somewhere here will be your average, right? Somewhere around 90. Just because of these two high, your average will go towards here, isn't it? Maybe 90K or 85K. Okay, and this is we call them as positively skewed graph. I told you I use the word skewed. Data is skewed, and this is positively skewed. Positively skewed means what? Most of the data is on the left side, and the tail. Okay, if you look at this, right? If you remember what I did, I drew you a tail like this, correct? If the tail is going along positive x-axis, this is right side is positive x, isn't it? Left side is negative x, correct? When you look at quadrant, this is x-axis, this is your y-axis, correct? So this is positive y, this is your negative y. This is positive x, this is negative x. So the tail is going towards right side. Right side means positive x-axis. This is how you remember. If I draw something like tail here and this here, then tail is going towards negative x-axis. We call it as negative x. So negatively skewed. Now, doesn't mean that negatively skewed is bad, positively skewed is good. Okay, depends upon data that you're measuring. Okay, if you talk about income, then positive, negatively skewed is better. You want more people to have high income, less people to have low income, right? That's what general tendency is. But things will not be like that, right? More people will have less income, and less people will have high income. So your graph will be positively skewed. So looking at the tail, where is tail going? Tail is going in this graph. Tail is going towards the right side, correct? So we say that this graph is positively skewed. Positively from statistics point of view. So we are talking from the status point of view. It's not sentiment. Positive means good, negative means bad. No. It's just that statistically it's going towards positive x-axis. So we are saying positively skewed. Understood? So yes, we'll stop here for today. And I'll share this so you can actually understand, read all this. Okay. So this is how we actually analyze. I'm going to show you towards the end one more report. Okay. So there are some people who writes wonderful report based on graphs. We'll do that. But today we spoke about central tendency, right? Tomorrow we'll talk about spread. What does that mean? If I tell you that, once I start my class at 5 o'clock, so what is our time? Our time is 7 o'clock, right? 7 p.m. is the right time. So what I'll do, one day I will start at 6 p.m. Another day I'll start at 8 p.m. And if you complain, I will say, see, what is the average of 6 and 8 p.m.? What is the average of 6 p.m. and 8 p.m.?
7.
7 p.m., right? So I'll see,
Mm.
I'm average is exact 7 p.m. So my process is very good. No, right? That's not the case. Right? So today we're only talking about how much are you looking at the center. But sometimes your central tendency, mean and median may be same, even then the process may be bad. Example I gave you. So first we discussed that mean alone is not enough, median alone is not enough, mean, median both you have to look at. And now I'm going to add one more thing to it tomorrow, that is called standard deviation. Okay, so sometimes mean, median will give you a lot of information, but not always. There would be some misinformation also if you just look at mean, median. So you also have to look at one more metric, which is standard deviation. Okay, so we'll talk about that tomorrow. We'll end it here. Any